Okay, so let me at least talk about where some of these things come from. So you can kind of get an idea. These are the derivatives of the inverse trig functions. These are going to be probably, the last two are natural log and e to the x. But besides those two, these would be the last flashcards that you're going to make for memorizing things. Because we've already done sine, cosine, and that kind of thing. But they're obviously going to be trickier. I will tell you, there are some. First of all, these two are the ones I see the most. Okay. Arcsine and arctan. And second of all, there's patterns. Like, do you notice what's the relationship between arcsine and arccosine? See how it's just the opposite? Yeah. And same thing here. The C's are negative, which also that is a pattern with the derivative of cosine is also negative, and cosecant is also negative, and cotangent. So hopefully somewhat that will help you, but all of these are opposites. So once you memorize arcsecant, the arccosecant is the opposite of that, and so on. Okay, so let me at least talk about where this comes from. So yesterday we talked about this y equals arcsine, how if this was true, what that means is the sine of y equals x, correct? Oops. Okay. And so if I were to make a triangle where that was true, I'm just making y this angle, theta, okay? And sine is opposite over hypotenuse. Okay, so what would this be? Yep, 1 squared minus x squared, take the square root. Okay, alright. So, would you agree with me that, I'm just going to write a statement, because all of them can come from this. If this angle, theta, remember, is y. Okay, because that's what this is saying, the sine of y equals x. Then, would you agree that the cosine of y, let's write it, where am I getting this from? Hold on. Cosine of y dy. Oh my god, my bad. Back up. Okay. Take this statement. We're going to use this triangle in a second. This is true according, right? I can make that judgment. Let's use implicit differentiation and take the derivative of both sides. What's the derivative of sine? Cosine y, but then we would need dy dx. Agreed? So if we took the derivative of this, we're taking the derivative of sine right now, which is really arcsine. Okay. What's the derivative of x? 1. Okay, let's solve for dy dx, because that's what we're trying to find. So dy dx equals 1 over cosine of y. Agreed? Okay, so then now let's use the triangle. If I would write cosine, if I would take this out and use the expression with x, cosine of y is adjacent over hypotenuse. Agreed? So isn't it the square root of 1 minus x squared over 1? Okay, I'm going to point out to you, this we did, and this was with respect to x. we just took the derivative of this, except we changed it into here. We just took the derivative of arc sine, and I want to point out to you that it matches what you see up here, except we used an x and they use a u here. The u is only there because if I have to use chain rule, then I have to do the dy dx business. Does that make sense? We have a 1 here because what's the derivative of x? 1. So that's really what that u prime is. Okay. You could do that with any of the trig functions to backtrack, but that would take way too long to do every time. So we're going to just use or memorize those. Okay. So yesterday I showed you that triangle, correct? But that's where it comes from. So now let's use it to take the derivative of a couple things. Okay, so first of all, this is where we have to use chain rule. So in this case, what's u? Yeah, u is t squared. So du or u prime, our book sometimes writes du, but u prime is what? 2t, agreed? Okay, so I'm going to just write in terms of t, so in terms of u, this would be arc sine of u, and according from the formula on the previous page, the derivative of that is du or u prime over the square root of 1 minus u squared. Agreed? Okay, so now let's substitute and do the derivative with respect to t. So on top, instead of u prime, I'm going to put the derivative of t squared, which is 2t, and on the bottom would be 1 minus t squared squared, which is t squared squared. Good. So the derivative would be 2t over 1 minus t to the 4th. What's that? This is easier than what we just did?
No, like what was done previously.
Oh, it isn't too bad. It's really just using a formula, but the hard thing might be memorizing the formulas, because right now we can refer and look back. Okay, so this is now what we have with 3 is, let's do a trig function that involves an inverse trig function, and that's going to mean a chain rule. Okay, so first I have the outer function, and what's the outer function? It's tangent, right? So what's the derivative of tangent? Good, so we're going to do secant squared, but remember we don't change the inside yet. Okay, now what do we have to do? Now we multiply by the derivative of what's inside. So it's just arc sine, and there's no chain rule in this one, so it would be 1 over, because the derivative of c is just 1, the square root of 1 minus t squared. And then we would simplify as best possible, but the only way we could simplify that would be put this portion on top and this portion on the bottom. Alright, so how are we doing so far? Let's do one with because I did 2 with arc sine, let's do one with arc tan a minute. Let's add another example. Let's say I gave you f of x is arc tan of 4x. Okay. So this is one that what's inside here is not just an x or a t or whatever, so we need to make sure we remember that like our u is 4x, and what's our du, or the derivative of u? 4. Okay. Or you can just remember, this is just chain rule, I'm just trying to help you sort through it. Alright, so if we go back and look at the derivative of arctangent of u, we see that it's the derivative of u over 1 plus u squared. And we've agreed our u is 4x, right? So f prime of x, for the u prime on top, I'm going to put a 4 over 1 plus 4x parentheses squared. And then I simplify it. Four over 1 plus 16x squared. Okay. So just to tie this in so we don't forget what we're really doing, let's use this to find the tangent line at x equals 1/4. Yeah.
How come you don't have to multiply that by 4?
I did. That's what why
That's just that it's in
it's
already.
in the problem already.
Okay.
Yeah. So the reason we have u prime on top is it's really just making sure you account for chain rule.
Okay.
Okay? Good question. In fact, in our book, I think it does 1 over, and then it says times du. So you're realizing that you're taking the derivative of something, that if it's not x, that you're taking the derivative of that. Okay, what do we need for a tangent line? We do. We need a point, right? So where do we get that from?
Plug in
The original function. All right, so if I put in 1/4, 4 times 1/4 is 1, agreed? So this is where we're not going to use our calculators. The arctan of 1, what we're thinking about is where on the unit circle is the tangent 1, what angle? Pi/4, good. So this is my x value, this is my y value. And then I need the slope. And to find the slope, I'm going to take the derivative at 1/4. And so I'm going to just plug that into this function right here. So 4 over 1 plus 16 times 1/4 squared. So this works out pretty nicely. Because 1/4 squared is 1 squared over 4 squared, right? So don't we get 16 times 1 over 16 then? So on the bottom, don't I get 1 plus 1? Which is 4 over 2, which is 2. Alright, so now I'm going to use my slope and my point. My tangent line would be y minus pi/4 equals 2 parentheses x minus 1/4.